Okay, so let's start. 2024 May June paper. Question number 1. An engine is used to remove water from a mine. The engine transfers energy to the water at a rate of 180 kilowatts and wastes energy at a rate of 60 kilowatts. Now, can you remember last week we did the 2022 paper? So, Janiru, we did the 2022 paper last week. Okay. So, therefore, in the 2022 paper also, if you remember, the first question, how come the camera went unavailable? How did that happen? You must be seeing from my normal camera. Let me just check my Osmo Pocket 3. Yeah. Okay. So anyway, in the 2022 paper also, you must remember the first question was related to power. Equals energy over time, right? Similarly, this question is also related to power. Can you see that? Okay. So give me 1 second, guys. Something must be wrong with the camera. In the sense, I'm gonna connect it again. Okay. So we are doing question number 3 now. So these videos are actually very relaxing, satisfactory. I'm gonna send a short. Okay, so others just look at this for now. Those who are in physical class, you can look at this short. What I'm gonna do is I'm gonna share the screen with online students here. Tab shares audio. Yes, share. Okay, hold on. I'm gonna switch it on.
That's called laminar flow. Each molecule follows the one before it with such precision that the water flows without any disturbance, creating an illusion of stillness.
Can you all see now? This water here, it is moving. It is moving, but we can't really see that it is moving. So this flow is called smooth. This flow is very smooth. No, it is known as laminar flow. Now imagine once you go to your, let's say, garden hose or something and open the tap, then you will see water going everywhere. It's not linear. It's not laminar. So we call that types of flow turbulent flows. So the condition required for stroke flow is an object must be small, spherical, and it must be in a laminar flow. It must be moving with the laminar flow. Got it? So the answer here that satisfied all of them is C. So that's it. Right? You all also understood? No? Right. Great. Question number 4. Which of the following expressions give a vector quantity? Which of the following expressions gives a vector quantity? So this is really easy. They are not checking whether you know these individual quantities. See, density into volume you get mass. Ne? Force into distance moved, you get work done. Mass into velocity, you get momentum. Power into time, you get energy. B and D, both of them are energies. So you know energies are never vectors. Last week also we talked about it. Now can you understand the 2022 and 2024 papers MCQs, if you think about them, have a lot of similarities. You should be able to feel it. Last week also I talked about vectors. This week also I am talking about vectors. So I'll tell you why this is happening at the end of the class. Anyway, B and D same, scalars. Both of them are energies. So both of them are taken out. A is mass a vector? No, it's a scalar. Therefore, A is also out. C is what is left, which is mass into velocity, which gives us, what does it give? Momentum. It gives us momentum. So then next what we have got here is question number 5. So for question number 4, the answer is, what is the answer? C. Question number 5. Question number 5, they are asking what is the stiffness of this ring. they are saying the student stretches. Okay, this is a length versus force graph. Now remember guys, not force versus length. A student stretches a spring of original length P. A student stretches a spring of original length P. Okay. Anyway, where were we? Question number? I think they are asking for question number 6. They are asking for question number 6. Okay. So what is question number 6, guys? In question number 6, they have basically said which of the following, no, same graph now. Which of the following expressions gives the work done stretching the spring from its original length P to length Q? So work done, how do we find work done? Work done in a, what do you call this, area under thing? Force versus extension graph. Can you remember how to find the work done in a force versus extension graph? How do we find the work done? Janiru, is your mic still not working? Alright. Now clear, now clear. Now I can hear you. Tell me so.
From the gradient?
No. Stiffness is what we found from the gradient, no? So here actually it's not really the gradient. I did not find stiffness through the gradient. Huh? Was it clear to you? Was this part clear?
Yes.
Yes. So I'm asking for question number 6. For question number 6, I'm asking how do we find the work done? Work done means the energy transferred. No? How do we find that energy associated with stretching the spring from Q to P in a using this graph? How do we find it? Can't remember.
From the area?
Yes, we have to take the area under that graph. So basically, what do you think the area that we have to take here? What do you think the area is? Janero, can you tell me? Now I'm going to draw. I'm going to draw this graph. So this is the length. This gives us the length. I'm going to mark it as L. And then what do you call the x-axis gives us the force. This is how they have drawn the graph. No, see. All right. What is the area that we have to take? Option number A is the whole area under this graph. This is option A. So whatever this is option A. Option B is only this part. So this is P, this is Q, and this is R. That's the graph, right? P, Q, R, yes. Only this part. So that is something like this and this. This is B, option B. Can you tell me, is it option A or option B that we have to choose? Just a guess. Option B. Why B? Why is it only this part? Because P is the original length. There has been no work done to get it to the original length. Do we need work done to get it to the original length? No, right? So only this part area we are taking. Only the area of this section. So what is the height? Q minus P is the height. What is the base? R is the base. So half times base times height. This is base, this is height. So have we got answers like this in question number 6? Q minus P times R over 2, yes. I'm sorry. So the answer is B, isn't it? B is the answer here. Okay. Question number 7. Question number 7. If we move on to question number 7 now, which of the following describes the center of gravity of an object? This is a very important part that we came across. I need to teach a very special theory point here. Now I'm going to be asking questions. Okay. Can someone tell me, no, not from the online class, right? You tell me what is meant by mass. Does anyone has an idea? What is meant by weight? What is meant by mass? First of all, tell me mass. What amount of substance an object has? Yes, that is correct. So mass means this theory is not like kind of related to this question, but I don't think you just need it for this question. Mass is defined as amount of substance, an object has, amount of substance an object has. That is what mass means. Then what is weight? Someone from online class tell me. Let's take Divya Tarani. Can you tell me what is weight? What is known as weight?
Is the force acting
Force acting. Yes, yes, yes. Force acting.
downward?
Oh, no, no, no. Downwards is very relevant. It's just this. It's very what do you call relative. Downwards is relative. You can't just say downwards. Imagine if you go to North Pole, and if you consider from there, South Pole will be upwards, right? But then we still say downwards for North Pole. No, no, no. It's not like that. So you can't say downwards just. Weight means force acting on a unit mass due to a gravitational field. Due to a gravitational field. Force acting on a unit mass due to a gravitational field. That is what weight means. Force acting on a unit mass due to a gravitational field. That is why we are using the equation W equals mg. This is the gravitational field. M is the mass, W is the weight. W is measured in newtons. W is measured in newtons. W means weight. Mass is measured in kilograms. So even though you go to a health clinic or a full body checkup, they say measure your weight, measure your weight. It's actually the mass that we are measuring in kilograms. Or if it is in pounds, it is the mass that we are measuring. Okay. So there is a special point that you need to know when learning about this mass and weight. It is, you have to remember, mass remains constant. Mass, what? Mass remains constant anywhere in the universe. Mass remains constant anywhere in the universe. That means wherever the planet is, mass doesn't change. So I told you, mass means the amount of substance an object has. Amount of substance an object has is dependent on its volume. Now if you have any question, ask me. Even if it might be not related to even what I am talking. Okay, doesn't matter. So mass remains constant anywhere in the universe. Amount of substance that object has, know what mass means. So the amount of substance relates with the volume. Volume of an object can't be changed no matter where you go in the universe. It can be changed when pressure increases, but not a solid, not for solids, it's for gases. It's for ideal gases, to be specific. Ideal gases are not existing in real world, no. That's why we call them ideal, no. Anyway, mass remains constant anywhere in the universe. You have to memorize that. But what about weight? I told you weight is the force acting on a unit mass due to a gravitational field. So let's say even the mass remains constant, gravitational field varies, no. Because of that, weight varies in the universe. Weight varies from planet to planet. I'm gonna say weight of an object varies. Weight of an object varies from planet to planet, or one planet to another planet. That is more neat if you write it like that. I have written from planet to planet. Okay. Anyway, this is what you need to know about weight and mass. First of all, write it down, and then I'll show you how this relates to center of gravity and center of mass. Okay, there's no such thing called center of mass in your syllabus, but I just teach it. In waves also there's a part like that. I'll explain it to you once we are doing unit 2, which we will be doing very pretty soon. Anyway, first of all, if you want, you can copy this down. Now I'm not pressuring anyone, no? If you want only, you can copy. If you think you actually need it, you can copy. . So in a paper class, what we are doing is not just giving answers to papers. Huh? In a paper class, the main goal is making you ready for the exam, that what you are about to get in the exam. Making sure you guys are up to the par when you go to the exam. That's what a paper class does. I mean, anyone can help you get those answers there. Finished. So, online class students, if you are finished, can you raise hands in this thing? Okay, Janindra is finished. All right, everyone is finished writing. Okay, great. Now, next, how this relates to center of mass and center of gravity. Let's see. So, I'm gonna keep these definitions here. So, listen up first of all. Center of gravity means point of an object where weight is concentrated. Center of gravity means point of an object where weight is concentrated. So, weight of an object concentrated means most of the weight is acting at that point. Weight is concentrated. So, from that point only, the force is acting. That is the reason weight is concentrated. It should be is. I should refill these marker pens. Anyway, that is the reason when we draw any object, we always mark its center of gravity and take the weight, the downward force relatively. Okay, the downward force is relative. This downward force, we are marking it from the center of gravity. That is the reason. There is something called the center of mass. Now, up to this point, everything is within your syllabus, but after this, it's not in your syllabus, but it is better to have an idea. Okay, center of mass, there's something called center of gravity. This is center of mass. Now don't confuse this. Center of mass of an object means that is actually the point where the whole volume, the whole amount of matter is supposed to be acting. So for example, in small objects, let's say I take a small square or something similar. In those small objects, that is acting at the same point as center of gravity. Okay, that is acting at the same point as center of gravity. So if you are doing engineering, you learn about center of mass and everything. Somehow, for now, I'll just say this. You have to know that when the object becomes larger and larger, center of gravity will be acting in a certain point, but center of mass always seems to be acting a little bit above it, a little bit above the center of gravity. Okay, this is center of mass, then cm, this is center of gravity at the bottom, cg. Okay, so then according to this part, we know that in the question the answer is supposed to be the point where weight of an object is considered to act. See, so the answer should be D. Yeah? Answer here is D.
What's the reason?
The reason here for the mass to be on top and the weight to be acting in the bottom. Yeah. So basically, here's the thing. When an object becomes larger, let's say large in the sense, it has to be like this. I'll take a real life example. Let's take Earth. You imagine somehow moon falls on top of Earth. It will disturb the equilibrium. It might even make us go out of the solar system. Sometimes, doesn't matter. What happens is, moon is I think like 1/6 or 1/7, 1/10 of Earth, the size of Earth. So what happens is this object is very large compared to Earth. No? Compared to Earth is larger still, but compared to other other structures on Earth, rocks and stuff, mountains and stuff, this seems to be very large. Then Earth also has a certain gravitational field. Earth's gravitational field is acting within it. It is 9.81. Because of that only, there's a weight acting, Rumika. So then, because this object is very large, it sometimes it might even go a little bit out of the gravitational field. It might even go past a point where the gravitational field starts to weaken. So in A2, you learn this. Gravitational field from the center of Earth to the surface, it increases. This is G. After that, it decreases like this exponentially. So this object seems to be very large, no? So center of gravity might be acting a little bit lower than it is supposed to be. Is it clear? Why? Because the object is still on top of Earth. Then what happens is center of mass anyway needs to be in the center, no? And that's actually being at the true center then. Did what I said clear?
So if let's say an object is isolated in like a vacuum, then
Then
both centers be
then yeah, obviously. So if we take the core of Earth's center of mass must also be in the center. Is it clear? Okay, right. So like that, if you have any questions, ask me. Okay, right. Now that's it. So for this question, center of gravity means the point where the weight of an object may be considered to act. That is the reason we are saying may be considered to act, not exactly where it is located, because it might change. Because of that's what I wanted to say here. That's the reason I gave you center of mass as well. I told you center of mass as well. Okay, so no need to write this down, just to have an idea. That is what the examiners expected there. Okay, right. I'm going to erase this. And also remember, sometimes, most of the time, okay, so the schools that I know, like Lyceum, they take questions from past papers. But sometimes, some schools, okay, they make these really hard mock papers. Like, those are never heard of. Some of those questions I've never even seen. I'm also seeing those questions for the first time sometimes. So then you don't need to worry about those papers and questions. The reason is, in Edexcel papers and Cambridge papers, examiners know what they are doing. Why do I say that? What do I mean by that? What I mean by that is, they have a very specific way of giving what you call questions. I'll explain this to you further, like towards the end of the class. Also, the reason this relates with the reason why we are seeing so many similarities from the 2022 paper in the 2024 paper. To see them exactly as I do, you have to have like a practice with those papers. I think this is like the 10th or 11th time I'm doing the same paper. This 2024 paper. Okay, that's why I'm seeing these similarities a lot. Yeah, anyway, let's move on to question number 8. Student is determining the acceleration of free fall g. Okay, alright. So now I think they are saying what is the time taken is high. He is getting a what do you call greater value than 9.81. What could be the explanation? So here, if the ball is moving downwards when the student starts the stopwatch, what will happen to time? The time taken will be decreased. Can you understand? If the time taken is decreased from the equation acceleration equals change in velocity over time, the acceleration should increase. Isn't that the correct answer then? Do you need to read any of the other answers at the bottom? No, right? Do we need to? Janiru, did you understand that? The reason how I took it? Yes or no? You did, right? Because if we are taking the equation, acceleration equals delta v over t. This is the common equation. No, I mean, this is not what we are exactly using here. But even though if we use it, it won't be that much of an issue. Final velocity minus initial velocity, no. So if we just drop the ball, the initial velocity is 0, no. Or he can use any other equation, equation of motion, anything else, okay? Doesn't matter, but simply think of this equation. Think from this equation. If you think about it, when time decreases, because when he started the stopwatch, they say the ball started moving downwards, no? Then that must mean the time that he had taken would have been less than the actual time. So then acceleration should increase, no? So that is the only possible explanation. If that is correct, if you are sure about your answer, then you don't even need to read any of the other answers. Straight away, mark that answer and go. It will save you a lot of time. But make sure you can't do that randomly. Yeah? If you haven't practiced past papers, as I've said, and you are just out of the blue moon, you are getting, right, this might be correct, I'm not going to read anything else. Don't be like that. This will only happen if you practice the past paper in the past paper plan I gave to you last week. Only if you do it in that manner, okay? Only if you do it in that manner, you can be this confident. Otherwise, actually read, you will end up using marks. Okay, question number 9. Student attached one end of the wire to a support Student added masses to the other end of the wire. As shown, student measured the corresponding extension for each end mass. Wire broke when the extension was small. Student replaced the wire with a second wire made of the same material. This had a large extension. They are asking what could be the reason for this large extension even though the wire is of the same material. If the wire has had a greater diameter, what would have happened? Wire would still break at the same extension. If it was shorter in length, greater diameter, it would be this thing in the same extension. Second wire had a longer length. Now that is a little bit acceptable. That is a little bit acceptable, but we are still not sure. A traditional student, let's say you are reading this question for the first time, you won't still be definitely sure that that is the correct answer. That happens in the exam. Okay. Now if you look at the third question, sorry, the third answer they have said is the second wire had a smaller diameter. In part A, if you look at part A, they say the second wire had a greater diameter and now a smaller diameter. Contradiction. Both can't be true, no? Only one can be true. So they have given both of them. Then D, if you look at D, the second wire had a shorter length. And if you look at B again, second wire had a longer length. So you are wondering whether it's shorter or whether it's longer. How do we get the answer here? What is the principle that we have to use to take the answer here? We can use, they are using the same mass, no? They are using the same masses. So we can use this expression to get the answer. Stress over strain, have you heard? Young's modulus equals stress over strain. We can use this expression to get the answer. Take Young's modulus as y, you can take it as e, anything doesn't matter. So then stress remains same, no? Force over area. So it's force over area, okay? Force over area. So we'll take force over area divided by what is extension? Sorry, what is strain? Extension over original length. So some people say x as extension, L as original length. Then this will be x, this will be L. Okay, right. So Young's modulus remains constant. Why? It is the same wire. Extension, they say extension is increased. Extension is increased. So what can we do? I am going to take extension here so that we can clearly see. F is also constant divided by E, which is also constant. Then there is L, then there is A. What can happen here? How do we get the answer here? What were the methods you guys used? Let's say, let me check your papers. Hold on. Second wire had a longer length, says Divyatharani. Rumika was also saying, Rumika, here, alright, okay. In your question number 8, I just saw this. Did you mark D and then marked A?
So I cut the D and put A.
You cut the D and put A. Alright, okay. So for initially you mark D. See, you have done this allotment. If you look at these papers, was this the first time you did these papers or the second time?
This paper.
Yeah?
Yeah, this is the first time.
This is the first time. See, if in question number 5 also you have cut this twice. In 6 also you have cut this twice. Okay, here's the thing. If you go to Harvard, right? In Harvard they teach you never look at an MCQ twice. That means once you take an answer, never cut it and mark it twice in the second time. They actually teach it to you. There's a research paper published. If you go, you can look into it. They say this happens, okay? Once you take an answer to a paper, once you take an answer to a question, automatically in the exam this happens, okay? Your brain shuts down to that question again. Once you go and look at it for the second time, in MCQ this happens, not in essays. Essays you must look at the MCQs in the second time, you must double check your answers. But for MCQs, never double check your answers, you will end up doubting yourself. You think this for a second and tell me whether it's true or not. Haven't that happened? Like haven't there been instances where you have pick the correct answer first and then once you went to overthink it second time, especially in calculation MCQ questions, there's a good chance that you might have gotten it wrong. But in theory MCQ questions it's not like that. In theory MCQ questions basically there's a good chance that you might have gotten it wrong in the first time. This is for calculations. So for calculations, try to get the answer in the first time itself as possible. In the first time as possible, try to get the answer. If possible, if you are getting the answer in the first time, try to get the answer in the first time. Make sure you do the calculation keenly, methodically. Then you will end up getting the answer. Let's say, let's see. What? So here we are ended up with this question, right? This is the expression we are ended up with. We are ending up with. Otherwise, there's no other else logical explanation to get this answer. No? This is the only way that we have using Lang's modulus. So here, this is the extension. They are saying the second one will have a higher extension. But this area, we can see area is in the denominator, L is in the numerator. Can you tell me, does area has an effect on extension? Does cross-sectional area, does it has an effect on extension? What do you think? What do you think, guys? It does not. Raise your hands if you say it does not. Online students, you guys can raise your hands through the meeting. So you if raise your hands if you are saying area does not affect the extension, cross sectional area. Okay, Divya Tarani is raising their hands. Okay, raise your hand. So if you are saying area does affect extension, okay, like area with cross sectional area, extension changes. No, that's what you are saying, no, right? Rumika, tell me why you said that. What was the reason to say area changes with diameter? Area changes with cross sectional area. Sorry, not area, extension.
According to that, so according to that Young modulus equation, if
Yeah.
all those if all those other quantities are constant, then I mean, if you're changing A, then obviously the extension should also change. According, like mathematically, that's what. Yeah, I don't know.
Mathematically, you are saying it's correct. There is a logic in that. Yes. Extension, so if you think about it, logically, extension of a material should change with its cross sectional area. That is true. So basically, a thicker material with a larger cross sectional area will stretch less than a thinner one when subjected to a same force. Okay, that is true. That is true. But now look at the question. So Divyatarani, that is true. Huh? It changes with cross section. But if you look at the question, see how closely they are asking this. Student replaced the wire with a second wire made of a same material. Wire had a large extension before breaking. Wire has had a large extension before breaking. So how do we get the answer here? What do you think is the answer? So we know for so far when the area of the material increases, extension decreases, area decreases, extension increases. Isn't it? Isn't that what happens, Rumika? When area decreases only, no extension increases. And now do you understand what has happened here? They are saying the extension has increased. So if extension has increased, area can't have been decreased, right? Because if you really think about it, extension of a material changes with the cross-sectional area. A thicker material will stretch less than a thinner one when subjected to the same force. Area decreases, that is a thinner material, it will stretch more. A thicker material which it will what you call stretch less. However, what is the most sensible answer here? If you think of the most sensible answer, what is the most sensible answer here? The sensible answer seems to be L, right? When it increases, straight away it increases. When it decreases, straight away it decreases. So what would have happened to students who have marked answer A as the answer? Because if you think about it, A is also correct. Okay, A is also correct. That is true. But what would have happened to the students who have marked A as the answer? What do you think? Are there anyone who marked A as their answer? Janur, what's the answer that you marked? You all, are there anyone who marked A? Everyone has marked B, no? Did you all look at the marking scheme? Janiru, did you mark A? Yes or no? Those who marked A, can you raise their hands? You marked A. Rumika, have you marked A or B, man? I can't see this thing. Your
First time after here, then
Alright, first time you marked A, then B. Okay, okay. No, in the exam, it wouldn't be much of an issue because anyway, what do you call, you are going to have to, what do you call, fill in the boxes, no? Sorry, not fill in the boxes. That No, sorry, that's not for you guys. That's for Cambridge AL, MCQ paper. Do not mark in the exam like this. Okay? Never mark in the exam like this. Right? I for a brief second I thought you're also getting that, what do you call, they get a separate sheet that can be marked. Never mark in the exam like this, huh? At like so what you can do is take a pencil. First of all mark, and then if you have any doubts you can erase and then clearly mark it. Otherwise don't do that, huh? Oh, what you can do is, let's say you actually got something marked in the pen and then you want to change it later. Then what you can do is cut it out completely. Cut it out completely and then like, not like this, it's ugly, no. Cut it out completely using one single line without it making it look like a, what you call, star. Cut it out straight away with one single line and then mark the other one. Your best option. Anyway, here you are supposed to write down, what do you call, take the best possible answer. In this question you are supposed to take the best possible answer. So even though that logic was correct, even though this logic is correct, why didn't you all choose A is increasing and decreasing, area is increasing, area is decreasing? That is not the best possible answer, man. That is not the best possible answer, because sometimes there are some scenarios, even though it looks like this mathematically, it doesn't work. There are some scenarios that doesn't work. So if you have done this practical, this is a practical that must be done. Okay, people usually, teachers do this practical at school lab. Some do, some don't. You'll understand we are taking a material with longer length. If you do this practical, only when length changes, this extension increases, not when the diameter changes. Is it clear? This is not like, what do you call, those clay, no? They have this clay dough, right? In clay dough, if you use like a thicker, what do you call, if you make a thicker this thing and add that, what do you call, these things, it will like increase, it will extend a lot. But not in real life. In real life, ropes and everything, these extensions are very small. These extensions, when you increase area, when you increase the cross-sectional area, the extension that is occurring is almost negligible. So only if you increase length, you can see a, what do you call, actually mattering extension, which will actually matter. That is the reason B is given here as the answer in the marking scheme. Was that clear? Those who got it clear, raise their hands. Those who didn't, just lower your hands. Okay.
So in all scenarios, the area would so it will the area would anyway change the extension, right?
Yeah, area would change the extension. That is correct, but it will be negligible. So imagine, for example, imagine now there's a wire like this, okay, and then I increase the radius twice. That means the diameter increases. No, it will be something like this. Yes, the extension will change, but it will be negligible. So for us to get a extension that actually matters, it will we have to be like something like this before breaking. Is it clear? So then the best possible option is to increase the length. If I had the same length and I increase the length of this, the extension has a much more chance to extend more compared to this one. That is the reason. Got it? Okay. Right. Now question number 10. A ship mass this much, acceleration, okay. What is the magnitude of drag force? Engine, acceleration, okay. So this is where you have to actually take the resultant force. You have to find, you have to use F equals ma, I think, isn't it? Isn't it F equals ma? Yeah. Yes. So here, this is what's happening. A ship has a mass of 1.2 times 10 to the power 7 kilograms, has an acceleration of 0.03 meters per square second. Force produced by the ship's engine is 8. Drag force is acting in the opposite direction of the motion of the ship, right? So this is a scenario where you have to use the resultant force. The ship is moving forward. Is this the ship? No, this can't be a ship, obviously. Something like this, okay? Ship. This is not a ship, this is like a boat, okay? Those paper boats. Drag force is always acting in the opposite direction. You can think of it like a frictional force. It might be due to this water, it might be due to air, doesn't matter. Okay? They just say drag force. Because of the force given by ship's engine, this is moving 8 times 10 to the power 5 newtons. Drag force, you think of drag force like friction. So the answer is 8 times 10 to the power 5. How do we calculate drag force? Mass times acceleration, ma. F equals m in the other direction, which is 1.2 times 10 to the power 7 times what? 0.03. So the answer is, it should be subtracted. No, why? The ship is always already moving. No? So the moving direction is positive. This is negative. Answer is A, I think. It is A. Okay. Question number 11. Very easy question. Question number 11. Somehow we'll try to. Okay. Why is your hand up, guys? Divya, Tarani, and Johnny. Alright. Okay. Question number 11. Train moves up an inclined track at constant velocity. Train moves through a vertical height of 25 meters. Show the GPE gained by the train 400 megajoules. If you have any issues with the prefixes, let me know. Rumika, your megajoules look like microjoules. Make sure you write capital letter correctly in the exam, okay? Yeah. Yes. So here to get the answer for this question, Janidu, you have to just use mgh. Mass times gravitational acceleration times the height, vertical height moved by the train. That's it. You'll get 400 something, equate it to 400 megajoules. Then the train has an output energy of 20, takes 35, calculate the work done by resistive forces. So what do we do here? We use the equation they have given. Look at the quantities they have given. They have given us a power. They have given us a time. We are supposed to find energy. They have also said at this energy when the train moved 25 meters. So then power equals work done divided by time. So work done will be equal to power multiplied by time. Isn't it? In question number 11 part B, work done equals power multiplied by time. So the power here is 2, How much is the power? 20 times 10 to the power 6 watts. Time is 35 seconds. So once you have to multiply that, you'll get the total work done by the train. So power is how much? 20 times 10 to the power 6 times 35 seconds. So this we get as Js minus 1, this as seconds. You don't need to put the units everywhere. You will get full marks if you put the units only to the what you call last answer. To the final answer, if your final answer has units, that's enough. So remember, when I said I always say students need to learn how to write in the marking scheme. What I mean by that is not studying the marking scheme and going to the exam. If you can do that, that's really good. Huh? That's actually good. That's actually a good method to learn. But however, that's not what I mean there. In there, what I say is writing the answer in a meaningful manner. What does a meaningful manner means? Meaningful manner doesn't mean straight away writing the final answer. No. Not even starting your question with this. First of all, you have to state the equation that you are taking the answer from. W equals P into T, P equals W over T. And then only you can straight away move on to this step. Is it clear? So solving part in this question, you get 1 mark. And for the final answer, you get 1 mark. Sorry, solving part 2 marks, final answer 1 mark. Once you do this, you will get the total work done by the train, which is 70 times 10 to the power 6. So 7 times 10 to the power 7. That is the answer. Sorry. 7 times 10 to the power 8. 20, 30, 700. No? 10 to the power 8 joules. Previously, in the previous question, we have found that the gravitational potential energy gained by the train is 400. They are saying calculate the work done against resistive forces. If the gravitational potential energy that gained by the train, that means the energy gained by the train, the total useful energy is 4.17 megajoules, okay, times 10 to the power 6, no? Sorry, is it 4.17? No, it's 400. So we'll take it as 4.17 times 10 to the power 8. If this is this much, and this is the total energy. So this is the total, this is the useful. They are asking for friction means, resistive means wasted, no? 7 minus 4.17 times 10 to the power 8. So what is the answer? 2.83. 2.83 10 times 10 to the power 8 joules. That's the answer. If you have got that answer, you get full marks. 283 megajoules. That is correct. Divyatarani. 2.83 10 to the power 8 joules. That is correct, Rumika. Everyone else got this, right? Yeah. There is an iceberg now. This is also a very crucial question that we get here. An iceberg of large mass. Iceberg can be modeled as a rectangular block of ice. Okay. Right. So you have to get the answer to this question, you have to know a crucial theory part. What is that theory? You have to know that, alright, for this, yeah. You have to know that at equilibrium, when an object is floating, the weight of the water displaced by that object is equal to the upthrust acting on it. Okay. Also, if an object is floating, its upthrust is equal to the weight of that object. So the weight is equal to the upthrust, which is equal to the weight of the water displaced. Is it clear? Should be clear. So then let's look at how we can use it in this question. Part A, calculate the weight of the ice block. So when you are supposed to calculate the weight of the ice block, we need to calculate the volume of seawater displaced. To calculate volume, they have given us density. When they have given us density, that means we have to do what? We have to use density, multiply it by the volume, get the mass, use W equals mg and find the weight or the upthrust acting on it, which is also equal to the weight of the block. Okay. So I'll Janiru, did you got this answer to the question to this question 12a?
Sir, go to the group. Researchers.
Question number 12, part A, you got the answer, right?
Sir, go to section question B.
You couldn't do question B, but you did question A.
No, the section B. I mean, section B.
Section B in the sense?
Uh, after the MCs,
Yeah. You couldn't do
so I got the
what do you
paper
call the
like
essays?
half an hour.
Right.
I got the paper like half an hour.
Yeah. You joined today, no? So yeah. Anyway, so then next day when you are coming, you actually have to get these papers done, na? Okay. So what Divyatarani has done here is correct. We wrote G straight away. It's very simple. You get marks here. Rumiko also, what you have done, yes, she has taken weight equals upthrust, and then this and that. So your answers are correct. 3500 6.7. Can you guys give me your papers as well? Because that's the most crucial theory part that you have to know here, which you guys seem to know already. Hold on, give me your papers. Oh no, I'll come there. Record. When the density is less, what happens in question number 12 part B? They say the density is less than seawater. No? When the density is less, what happens? What happens to upthrust? The upthrust decreases, right? Or does it? What will happen to volume? Volume will remain constant. So what can you say about this? Weight of the block of ice equals to the weight of the displaced water. In lower density seawater, a greater volume of water must be displaced. Don't try to take from the equations. That's what I said. So Divyatarani, if you look at your answer, since weight is constant, W equals U, upthrust is also constant. So density of liquid is inversely proportional to the volume of the object. So when density decreases, volume somewhat below water surface increases according to U rho J. They have asked you to explain why that is happening. They have asked you to explain why that is happening. You have said you have also like exaggerated kind of the question that they have asked. So a model answer here should be, let me check Rumika's density of the seawater is less, upthrust is acting. Okay. Upthrust equals weight of water displaced, then the upthrust acting on the ice is less. Yeah, you have also gone with the same logic. See, that is why I first of all I read all of them and I said no at the end. A model answer should have something like this. It should start with the reasoning. They are asking explain why no. Weight of the block of ice equals the weight of water displaced. Anyone can get part A correct. Okay. Question number 12, part A, getting correct is not that much of an issue. Getting part B correct is the real problem here. Weight of the block of iceberg equals the weight of water displaced. That must be written first. Can you, if you really think of it in logically you have to think now, not from the equations. That's why I discourage all those equations writing. If you logically think about it, can you understand when density is lower, the amount of matter that is there is that also become lower? Does the amount of matter becomes lower? Does the volume of the object shrink? Does the iceberg become small? No, right? Iceberg doesn't become small. Density of water decreases. That means to be equal to that amount of mass, to that amount of weight, and that is also floating, no? To be equal to that, the upthrust must be kept constant, right? For upthrust, if upthrust is supposed to be constant, what should happen to the volume of liquid what do you call displaced? Volume of liquid displaced should increase just to keep upthrust constant. Then in lower density water, in lower density liquid, a greater volume of water must be displaced. That's it. That's it. That's all you have to say. Okay. So remember, you have a pretty good chance of getting a question like this in this year's exam. Huh? Okay. So make sure to take notes. So Johnny, true, even though you have still you haven't attempted the question, it's better to write it down this time. Huh? weight of the block of iceberg equals to the weight of water displaced. That should be the first part. Then upthrust, sorry, not the upthrust, you can say therefore in less density seawater, a greater volume of water must be displaced for iceberg to float. Another point the examiners are testing you here is how well you manage your time. So most of the students, most of the teachers don't teach this. So this is what's happening now. If you look at the initial couple of questions, guys, if you look at the initial couple of questions, can you see that those questions are very small, but sometime somewhere in between those questions they have put parts like this. Question number 12b is a good example where they are only giving 2 marks. They are giving a very low number of marks, but still the gravity is a lot. You have to think a lot. A student who's a thinker, who's a natural thinker, might be stuck in this question for like 5, 6, 7, 8 minutes, while he has around 2.5 to 3 minutes to answer this question. So if this happens in the beginning of the paper, can you understand how much time he'll lose? Because here's the thing, here's my logic. The more longer the question is, the more easier it gets. Why? Without straight away asking you to get the answer, the final answer, they'll give you the process of getting the answer step by step by step. So then that question will be more easier. Also, they'll have to write a lot when the question is longer. So then when creating a question like this is what examiners do, okay? They never tell this to students, so listen carefully. They make sure they allocate the timing. So you are given the time limit for this paper, no? They allocate something called reading time. They are not giving it in the paper. They are not giving it in your exam. Okay, you are not getting a reading time in your exam, but they are allocating it in the question. So let's say a question becomes lengthy. Then you only have to write a lot less compared to some. There are some questions. So once you do many past papers, you will be able to see the pattern. You will at least roughly you will be able to see the pattern. I mean, you will be able to see it like super clearly, 100%, 95% clear once you do it like 10, 15 times. That happens with repetitions. That happens only in past papers. But still, after you do all these 17 to 16 papers that I asked you to do in the last week's class, you'll be at least able to spot the pattern. What's exactly happening here? So then, let's say you come across a question like this, you are exactly not sure on how to get the answer. What you need to do is circle that question, move on to the next part. Just circle it, move on to the next part. Because sometimes within the time you are wasting to do this part B question number 12 part B, there might be other questions which you can answer, like solving questions, equations. And also what I've seen what students do is sometimes when they get a full question, let's say they are unable to do part A, they straight away leave part B and C as well. Sometimes part B and C is totally irrelevant to the question, especially in unit 3. Unit 3 you will see it. So there was a student of mine, she didn't know electricity. So she was like, sir, I can't do electricity unit 3, I can't do electricity unit 3. And then we finally did electricity unit 3. She hasn't done electricity in unit 2. For unit 3 papers, you don't need electricity to do electricity theory to do electricity questions that much. That's only in unit 3, yeah? That's not common for other 2 papers. Anyway, question number 13, moving on. They are saying, this is about, I think, finishing of a car. Yes, finish line. Last week I did this question to another student. Anyway, doesn't matter. 2 cars, A and B, are racing a longer track. Car A has a constant velocity of 93 meters per second. Okay, car A is now ahead. It's anyway ahead in the starting position. Car B is what is moving with an acceleration. Car B is accelerating with a constant acceleration 14 ms minus 2. No, yeah, 14 ms minus 2. B has an initial velocity of 93 meters per second. So both of them have, when car B is 9 meters behind car A, both of them are at the same velocity. Car A is moving with constant velocity though. Car B is increasing velocity. It's moving with an acceleration. At that moment, it is 93 meters per second. You have to get that thing into your head. Okay. Show that car A and car B are side by side after a time of about 1.1 seconds. So what have we got to do here? Both of you have got the answer there correctly. Yes. But we have to use S equals ut equation, and we have to take a certain, what do you call, kind of like an assumption here. It's not really an assumption, no, not an assumption. We have to use something called relative motion. Relative motion. We'll see. I am going to assume, okay, I am, so both these cars are, I am going to think, I'm going, let's say we apply S equals ut plus half at squared equation. See, equation of motion. You have to remember all the equations of motion. There are 4 equations of motion. I'll just write down the equations of motions here. S equals ut plus half at squared, that is 1. Then V equals u plus at. Then V squared equals u squared plus 2as. What's the last one? S equals u plus v over 2 into t. Some say half times u plus v into t. Same thing. These are the 4 equations of motion. So today paper actually might take a little bit more than we expected because I had to explain. However, we'll still try to do the maximum number of questions. Guess we actually have a pretty good amount of time remaining. Maybe if we just try, we can get past question number 17, 18. Let's see. Still in 13 though. We'll see. Now here we have to use S equals ut plus half at squared in the horizontal direction. This is how we use this equation. Now when doing these questions, never look at the marking scheme. Never ever do that mistake. Okay, especially for the May June papers. May June papers, do it without looking at the marking scheme. If Jan Feb, if you want to, you can just refer to the marking scheme after doing the paper though, not while doing the paper. Okay, because don't make your brain addicted to that, in the sense don't make your brain get used to that way of doing the doing papers, because if you do that you won't have the marking scheme in the exam. So your brain will be panicked there. So train your brain. It's like going to the gym, which I haven't gone. Obviously you guys can see that, which I haven't gone in like a year. Should start after this batch. I should get a good break anyway, it doesn't matter. S equals ut plus half at squared. So how do we use this equation here? We have to assume the total time taken is t. For what though? For what is this total time taken? For both the cars, the total time taken for car B to finish is t. So what are they saying in the question? Show that car A and B are side by side after 1.1 second. Okay. So t means the time car A and B are side by side. Car A and B are side by side. Side by side. Take it like that. Without this assumption, you can't take the answer here. Actually, you can't take the answer. So I am going to think of myself as car B. Because why? Why am I car B? Why am I choosing car B? Does car A has an acceleration? No, right? Only car B has an acceleration. That is the car that we have to choose. Car B is 9 meters behind car A. And at that instant, we know it is moving with the velocity 93 meters per second, which it will move in a time t. Now we know that it is increasing, but we are starting from the instant where this starts to move when it is 9 meters away. So that distance is also being added to 9 meters. Then what is the initial starting velocity? 93 times t, which we don't know as well, plus half times what is acceleration? 14. 14 is acceleration times t squared. If you can write this expression straight away, this is going to be a lot easier. Then 93t gets removed, gets subtracted. 9 meters is equal to half 14t squared. So 7t squared, right? 9 over 7 is equal to t squared. Is it clear? Straight after this method, this what do you call this? We can move on to here. We can move on to this step. T equals 9 over 7 square root. This is how you get the answer. You will get the answer as 1.13 seconds once you solve this. Does anyone have questions related to here? If we didn't take this assumption, we can't get the answer. Remember, car A is already 9 meters ahead of car B. Why did we choose car B? Because car A doesn't have an acceleration that we can use here. Is it clear? Yes. Question number 13, part B. At the instant shown, car A is 100 meters from the finish line. Deduce whether car A reaches the finish line before car B. Now, listen up very carefully. We know that car A and B will be in par with each other, will be side by side after 1.13 seconds. Right? So, we know that car A travels at constant velocity 93 meters per second. Is it clear? 93 meters per second. Then what happens? When car A is traveling at constant velocity 93 meters per second, you have to know that to travel 100 meters at 93 seconds meters per second, okay, this over time is 93. This is meters per second. This is the distance. This is the time taken. So we can find how much time is taken for car A to travel 100 meters, right? Can you, if you solve this, you will get that it is less than 1.13 seconds. This answer, I'm going to take this time as t dash. Okay, t dash will be less than, because I can't remember. I think this is 1.075 or something. T dash is less than t that we found here, 1.13. So therefore, can you understand? Before car B comes near car A, comes next to car A, it finishes first. So all you gotta do is use this expression and just explain it in one single sentence, because you are only given, I think, 3 marks. You can either do it in that manner, or else there's another way actually to do this. There's another way even. The second way is this. I'm going to erase the top part. The second way is, look at how much distance. Look at how much distance car B has. Car B has 9 meters plus 100 meters. Ne? Why? It is 9 meters behind that. No? So we can use S equals UT plus half AT squared for car B. 109. S equals UT. What is U? 93 times time taken for B. Let's take as we took TA. Yeah, we'll make this TA. Okay, TA kilogram. We'll make this TB plus half times 14 times TB squared. Then what happens? This method is a bit what do you call longer. You can straight away use. Can you remember that equation? X equals minus B. Minus B squared minus 4AC over 2A. By using that, you can find the value for TB. Okay. By using that, by making this equation, after solving this, by making this equation this manner, A squared equals B squared minus C, like that, AX plus B plus C, you can get what is TB, and TB you will get a value. After you get the value for TB shows how much time is taken for car B to pass the finish line. If we can show that TB is greater than TA, then still we can say this is correct. Is it clear? Was that clear? So if it was clear, can you guys raise your hands?
So,
Yeah? Yeah.
so the cars never, I mean, car A and B never, like, they were never side by side, right? Before the finish line, only after the finish line they were side by side.
Yes, after exactly at 1.13 seconds only, car B came near car A. After 1.13 seconds, car B surpassed car A. Before 1.13 seconds, see, before 1.13 seconds, car B was behind car A. It had 109 meters to travel. Okay. Okay, guys, you can put down your hands. Right. Question number 14 now. In question number 14, shall I erase this? I'll just go. No, you guys are still writing, no? Yeah, I'll just give you like a couple of seconds in the sense, couple of minutes. Yeah, take your time and get this done somehow. So write it completely. Yeah, I'm not in a rush. Okay, there's no need to rush. Okay. Now let's get on with these questions again. Question number 14. Grain of sand quickly reaches terminal velocity when it falls into water. State why the grain of sand reaches terminal velocity. So this is the part where I teach you all or revise you all about terminal velocity. Look at the board closely. It's a very easy part. Huh? So I always say don't complicate things than they are supposed to be. You know, this is the most simple way of teaching terminal velocity. So let's say I'm teaching a normal theory class. This is how I teach theory class as well. But the difference is I'll teach here a little bit faster. That's it. This is the shortest note that you can possibly get now. So look at the board closely. Okay, guys, look. Stop talking. Hold on. Look at the board. Right? Okay. Now imagine this is for a grain of sand. I'm gonna take a sphere. Let's just imagine this sphere is what you call dropped from a certain height. What are the two forces acting on this sphere? I'm gonna say there are not two, like, yeah, there are two main forces acting on this sphere. What are those two? Weight is acting first of all, and obviously air is a fluid, so upthrust is acting, air resistance is acting. But commonly, I am going to take all of those resistive forces as air resistance in the opposite direction. So let's take it as R. Whatever the force that is acting opposite direction to this sphere, to the motion of this sphere. So weight is acting, air resistance is acting when the object is falling. I'm going to say this object is falling with an acceleration. Usually when an object is falling, it's falling with gravitational acceleration on Earth. On Earth's gravitational acceleration, which is 9.81 meters per square second. So basically you have to understand here, guys, you have to know that what is happening to an object when it falls under an acceleration. First of all, tell that to me. Its velocity is increasing, correct? For an object under acceleration, velocity is increasing. So I'm going to say acceleration, velocity is increasing. Remember these terms. A means acceleration, V means velocity. When falling under a constant acceleration, which is equal to gravitational acceleration 9.81, which is this, the velocity of the object increases. Yes. So also I didn't think I was able to, I got to teach this to you. Actually, acceleration means, I'm lucky that it was not my shirt. Anyway, acceleration means how much velocity increases every second. That is the most simplest definition for acceleration. So in my IGCSE class, this is how I teach the kids. For example, imagine 10 meters per square second you are given a Bugatti. මොකක්ද අපි ගමු මොකක්ද අලුත් එක Tobelianද can't remember. Anyway, one of thing it has many, what do you call this thing, with the W12 engine. You guys are not into cars, ne? Tobelianද මොකක්ද I can't remember. Anyway, forget the Bugatti. Let's take අපි ගමු ළඟදි මම දැක්කා Porsche 911 GTS. It is traveling with a velocity, with an acceleration of 10 meters per square second. What does that mean? That means velocity of the car. Velocity of the car is increasing by 10 meters per second every second. People think they know this when they talk about acceleration, but when I actually ask what is the definition, they never say this. හරිම රෙයාලි තමයි මේ definition එක කට්ටිය කියන්නේ ඇහුවම. When I ask people what is the definition, rarely I get this answer. As velocity equals acceleration is velocity of the car is increasing by 10 meters per second every second. Every second term should be there. Rarely people tell me this. If I ask 100 students, only like 5 or 6 will tell me this definition. This is how you must understand acceleration. No? That is just a plus point. That is not related to terminal velocity. Huh? That should be taught before terminal velocity. I just gave it because I remembered it. Anyway, here what happens is acceleration is occurring, so velocity is increasing in this manner. That means velocity of a falling object is increasing by 9.81 meters per second every second. No? Then you have to understand, this is a theory principle. When velocity increases, air resistance increases. So air resistance means commonly all the resistive forces acting. Huh? When velocity increases, resistance increases. However, weight is kept constant. Weight can't increase. No, weight is the amount of weight is the force acting on this mass, right? This sphere of a constant mass. No. So then weight remains constant. When air resistance is increasing and weight remains constant, since both of these are forces, at one point I can say, weight will be equal to air resistance. Weight will be equal to air resistance. Is it clear? Weight will be equal to air resistance. Then what happens? When weight is equal to air resistance, resultant force, what happens to resultant force? Resultant force becomes 0. From Newton's second law, then F equals ma, we know acceleration becomes 0. At 0 acceleration, from Newton's first law, we know that object travels with constant velocity. Constant what? Constant velocity. Harida. So now we can finally say this constant velocity is known as terminal velocity. Terminal velocity. This constant velocity is known as terminal velocity. Also, you have to know this is the maximum velocity that can be attained by any object falling. How? If the weight is increased, it will take, and the surface area remains constant, let's say, then it will take more time for the air resistance to attain. Then this terminal velocity of that object might be higher. If we take a sphere with the same surface area but like less mass, then let's say it's hollow, so therefore less mass, then terminal velocity will be attained quickly. So if we take a water drop, that is the scenario that's happening. Water drop attains terminal velocity very quickly. Otherwise, if it comes with increasing speed from the position that it's been formed, and if we go out in rain, water droplets will slice through us. So we won't be able to go out in rain then. So yeah, that's the thing. Actually, this is not relevant to terminal velocity. Acceleration part, if you want, you can write it down. I'm going to mark it in black color. Okay, you should get that keyking sound as well. This is a ASMR mic. Anyway, this is it. This is terminal velocity. So Einstein said, if you actually know something, you should be able to teach it to a 6-year-old even. Would a 6-year-old actually understand this, guys? I don't know. I haven't taught this to a 6-year-old. Anyway, it doesn't matter. Did you all understand it? If you all understood terminal velocity, Raise your hands. All right, good, 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 good. Okay, great. Right, you can put down your hands. Now, those who want to copy this terminal velocity part can copy the terminal velocity part. Those who want to copy acceleration part can copy acceleration part. Uh, yeah, those who want to copy both can copy both. Do what you need to do. Let me know. I'll give you all 2 minutes and ask who is done. So then I'm just saying, while you guys are writing this, listen up. They say no, state why the grain of sand reaches terminal velocity. The answer is the resultant forces. You can since they are giving only 1 mark, you can either say the resistive forces become equal to its weight, or you can say resultant force becomes 0, something like that, which can only be written in one sentence. It's easy to write. You can say something like that and get full marks. It's just 1 mark. No? So let's say they have given like 5-6 marks. Then you'll have to explain it a lot. You have to explain the whole procedure if they have given like 5 marks. This is how I actually teach my normal, what do you call, students as well. Theory class students, and then I give a small note instead of writing these points, otherwise they'll forget anyway, if not. Right, finished. Okay, the reason I give short notes is because as a student I never liked writing long notes, so I gave the shortest note possible. Anyway, I mean everything's included. Huh? I'm not taking out facts to give the shortest note. Okay, if you are done with this, raise your hands. Don't take screenshots, online students. Don't take screenshots and take. If you're not done, I can give time. Okay. All right. Great. Great. All of you are done. Okay. 14A, I said the answer. Let's move on to 14B. You can put down your hands. Great. Spherical grain of sand has a weight of 4.3 times 10 to the power minus 5. Is it 850? My God, I saw it as 750. Right? Okay. Okay. A spherical grain of sand has a weight of 4.3 times 10 to the power minus 5. The grain of sand displaces water with a weight of 1.5 times 10 to the power minus 5 newtons. Terminal velocity of the grain of sand as it falls through the water is about 0.05 meters per second. Deduce whether Stokes' law applies to the grain of sand as it falls at terminal velocity. We are supposed to deduce whether Stokes' law applies. So how do we do this deduction? What are we supposed to do initially? They haven't given us, so we know that viscous drag, or F equals 6 pi eta RV. I'm going to erase this diagram. F equals 6 pi eta RV. Eta means coefficient of viscosity. Eta, eta, RV. X pi eta RV. Then x pi eta RV. Eta. Anyway, this is not erasing. I don't know why. It is happening. What has happened? Doesn't matter. F they haven't given. F we have to actually find. So you might think, since they have given this these values to us, right, 4.3 times 10 to the power minus 5, 1.5 times 10 to the power minus 5 newtons, you might feel like they have given us F. We have to use whatever the force that they are. We can guess and take F. No, no, no. If you thought like that, deep trouble you are in, Puta. You have to use the equation weight equals what? Upthrust plus drag. So if an object is downwards, upthrust and drag, weight equals that. So then you need to find drag by subtracting upthrust from weight. So then 4.3 times 10 to the power minus 5. Let me get another marker. 4.3 10 to the power minus 5 minus 1.5 10 to the power minus 5. You get the drag force. Then once you find it, 2.8 times 10 to the power minus 5, and uses in the equation 6 pi eta RV, we can easily find what is V. We can easily find what is V for this liquid. We can find what is V for this fluid. We can't say liquid, remember. We can easily find what is V. So if we find what is V, and if we are going to get a value, no, then we have to show that whether that value is equal or somewhere is it near to this 0.05 meters per second. If we can show that, easily you can get the answer. Let's check your answers. Did you all got it like this? Ah yes, everyone got it like this. Okay, then what about you guys? 14. The 2.8 that you have gotten. Alright. Yeah, so what do you call, Rumika, you have taken the drag force, no? You have equated the drag force if it was in that liquid, no? See, O can argue by comparing terminal velocities. Yes. So this is what I mean by meaningful manner. Even though in marking scheme they have given comparing these velocities, if you have taken this and you have written it like it, you get full marks here as well. So let's say you, Divya Tarani. Yeah, you have taken it from the, what do you call, this method, no? Yeah, Stokes law does not apply. That is correct. That is correct. What you have taken is also correct. So this manner that you have written, that is also good. It's a meaningful manner. You have written it in a meaningful manner. Okay, great. Now they are saying, next question, explain how Stokes law, how temperature of water affects terminal velocity of grain. So when temperature changes, what happens to viscosity? It's like this, okay? You think of ketchup. Ketchup, you get Kist, Edinburgh. You get those brands, no? In ketchup, we call it sauce. So then what happens? When the ketchup is inside the refrigerator for a long period of time, sometimes if it is like more than half used, it's very hard to get the ketchup out of the bottle, no? Why? Because the liquid is, we can feel that the sauce is very thick. So this thickness is what this coefficient of viscosity means. Viscous liquid means we are checking the thickness of a liquid. Checking viscosity of a liquid means checking the thickness. We call it a singular word. The singular word is uku kila pikino, right? We call it uku. Uku means like thick, okay, thickness. So anyway, if you have seen this VVAD, in VVADs they call it. Yeah, they call it. I can't act it out because the class is being recorded. If not, I would have acted it out how the actor says is. It's being recorded, yeah. So I have to upload it to YouTube as well, yeah. Anyway, that's what happens. So when temperature increases, let's say we keep the ketchup bottle, sometimes you forget it and keep it in the kitchen pantry or something. Then when you are going to use it again, it feels a little bit light. Feels the liquid is flowing more smoothly. The ketchup comes smoothly. Otherwise, you have to do this with the bottle, no? If you don't have that small cap inside where you can easily get it after pressing, if you don't have that, if you straight away take it from the bottle, that happens. So you have to say, as temperature increases, what happens to viscosity? The thickness decreases, then it's more easier for us to take it out. I mean, when it's cold, thickness remains the same. It's like the resistive forces increases. That's what happens. So value of terminal velocity increases from Stokes law. If you just write it like that, you can get it. F has to be the this thing, no? To make drag equal to the weight. So then to keep F constant, when eta decreases, terminal velocity increases. That's it. Okay, that's 14C. Moving on to question number 15. So we'll finish question number 15 as well. Then we'll only have 16, 17, 18 and 19. No? We'll finish those questions in the next week, right? Okay, I'm going to give you the next week's paper as well, guys, today. Next week when you're coming, get the 2023. 2020 what? Not unit 1 though. Huh? Get the 2023 unit 2 paper done. 2023 unit 2 May June. Okay, 2023 unit 2 May June. Now remember, I have given you all a table, right? I have given you all a table. No, I want, right, let's say who's a neat writer here. Divyatarane, after the class, can you send the image of those two tables that you have drawn for unit 1 and unit 2 to the class group?
Okay, sir.
Right? Okay. So Janeru, you look at those tables and you also create a table like that in the back page of your revision book. Huh? Okay. Okay. So then in that table, I'm going to be discussing all the May June papers. The remaining papers I'll tell you what to do with in the next day. Somehow 2023 unit 2 May June paper, but we are going to discuss question number 15 and then only we are going to leave the classroom. Okay. Question number 15. If we take question number 15, it's about momentum or conservation of momentum. There's a collision before scenario, after scenario. Show that velocity of ball A immediately after collision is about 0.05 meters per second. So then straight away, since they have given us the diagram, we can use the conservation of momentum. What is the conservation of momentum? Conservation of momentum means total moments before collision equals total moments after collisions. So this momentum principle is very important, guys. The reason is in A2 unit 4 also you've got momentum. So in A2 actually we are learning momentum when they are moving at angles. What happens when they are moving at angles? It's not much different. Okay, same thing again over. Somehow total momentum before the collision equals total momentum after collision. So then in the whole system you have to take the momentum. If this is not clear for you, if you need momentum detailed explanation of conservation of momentum principle and do some questions, you must let me know. Not now, let me know it as a private message. Okay, sometimes I might have recordings that I have done in previous classes. I might be able to send you that. If not, if I don't have them, next week in the beginning of the class I'll give you a detailed explanation of this conservation of momentum principle, but for now I'm just gonna write it down now. So they have given the masses of the ball separately, no? So mass of ball A is 0. They have the same mass, 0.165 times 0.739. This is the momentum before collision. I'm going to consider to the right as positive. Then does the ball B has a velocity? No. So I'm going to take 0.165, which is the mass of ball A and B both, times 0. This is also to this direction, but since it is 0, it's not used. Okay. I'm sorry. Okay. Now, next, what we have is give me 1 second. So next, what we have is this is what we have next. This is what we have next. So momentum here, this is momentum before collision, and then this is equal to momentum after collision. This is equal to momentum after collision. What is the momentum after collision? We see A moving with a velocity 0.165 times V. We don't know the velocity yet. That is moving to the right. So it is automatically positive. We are taking the right direction as positive. Then B. B is moving 0.165 times what? 0.691. It's moving to the right. There's a small trick that you can use here. This to this to this gets cancelled out. So V plus that is equal to this straight away. 0.739 minus 0.691 is equal to V. Imagine, let's say you are given this as an MCQ. If you are given this as an MCQ, guys, what you all have to do is never write the full length equation. Straight away take it like this. Take the velocity like this. It's way easier, right? Yeah. So then once you do this, you'll get the answer as 0.04. How much? This is 0.691. Yeah. You get the answer as 0.04 something. Yes, you should get the answer like that. Why isn't it coming? Yeah. Okay. So then part B, if you look at part B, they are saying to determine the decrease in total kinetic energy. So then initial kinetic energy you have to find. Initial kinetic energy you have to find. And then you have to find the final kinetic energy. Then if there is a difference, that's the difference that you have to take here. So then I'm pretty sure you have done that. Give me your papers as well. Three of you give me your papers. Hold on. Yes. So separately, you've taken the kinetic energies, no? Yeah, that is great. And Divya Dharani, now in your paper, you have equated this to 0.05. It doesn't has to be like that, nah? You can even keep it in 0.048. Okay, that is also still correct. It doesn't have to be always to three significant figures. Yes. So as long as you have taken the change here, you understand this, and it's very easy. Part C is the crucial part where you have to write down an explanation. During the collision, there is a resultant force on ball B from ball A. Resultant force on ball B from ball A. Okay? On ball B from ball A. Then, according to Newton's third law, there is explain in Newton's laws why ball A decelerates during the collision. Explain according to Newton's laws. Right? I think I lost a bit there. Was trying to send something, but okay. Explain using Newton's laws. So you have to state the two Newton's laws that are used here. You can either say Newton's third law. You can say from Newton's third law, or you can say from Newton's no, you have to use both the laws here. Newton's second law, F equals ma, resultant force acting, you can use that law. And then the second law should be every action has a Newton equal and opposite reaction. So ball B exerts a equal force in magnitude and opposite in direction on ball A. And according to Newton's second law, resultant force on A therefore causes A to decelerate. Something like that must be written. So remember, they have not said explain in terms of a Newton's law. They have said use Newton's laws. That means you have to use multiple laws. Even if you can say first law, from the first law, when an object is what you call given a resultant force, they get out of their balance state. No, objects which are moving continue to move with accelerations. No, even that, if you have written that, you get marks. So Romika, you have written according to Newton's second law, the force acceleration. So it encounters a negative acceleration. That means a deceleration. Yes, according to Newton's third law. Yes, that is correct. Yes. Yeah. So also a good point, Rumika. You have also always you have remember deceleration means a negative acceleration always. Huh? Deceleration simply means a negative acceleration, which is an acceleration acting in the opposite direction. We are only given an equation for acceleration. Acceleration equals delta v over t, v minus u over t. So when u becomes greater than v, it becomes a deceleration. When the starting velocity is greater, ending velocity is smaller, it becomes a deceleration. So then this acceleration becomes negative. Only that negative acceleration we call a deceleration. Okay, you have to understand that. So what is happening here? Okay, hold on. Right, let's just wait. It's disconnected. Understand. Always a deceleration is a negative acceleration. Deceleration means a negative acceleration, and if initial velocity is greater than the final velocity, this a becomes negative. Because of that only, we have a deceleration. We call this negative acceleration deceleration. Remember, there is no equation specifically for deceleration. Now most teachers teach it as a equation for deceleration. No, it's the same equation. Only know the required amount of facts. Don't know more than it, otherwise your entropy will increase. I'll explain that to you in the next day. Also remind me to explain you how the paper is made. 80-20 rule, I have to teach that to you in the next week. It's very crucial. I have to teach it to you before going to the exam. Somehow when you're coming the next day, I ask you to do 2023 Unit 2 May-June paper. Okay, May-June. Get this paper done when you're coming the next day. So that is it today for that is it today, guys. Okay, that is it for the class today. And Romika and what do you call Divyatarani, you will get the papers marked and papers marked probably within 2 days. One of my assistants will send it to you. If you didn't get any of the papers marked, like the papers that you sent, you have to let me know. Okay, so what I am doing is I am sending it to one of my past students. He or she is going to mark it and send it. I have them as my assistants. Okay, so then he or she will be marking it and sending it to you. If you had not got any of the previous papers, you have to let me know. Okay, so usually within 2 to 3 days you should get it. Okay, so that's it, guys. That is it for today. And the physical class students, anyway, they get the paper marks in the class itself. Yeah, that's it. That is it for today. So you guys can leave. Okay, you guys can leave now. And yeah, so Divyadarani, Rumika, goodbye. You also can leave. Right.